IT has not found a solution for it yet.
The open source technology is created by a number of freaks around the globe, but I promise it will be okay.
It's really easy to get started, but then the cost will just explode ridiculously over time.
Vendor locking is always there. If you decide to use Python, you are vendor locked. Welcome to the Internet of Things Equation podcast. I'm your host, Łukasz Malinowski, and let's get started with today's conversation. My today's guest decided to improve the industrial Internet of Things using open source technologies. As the co-founder and CTO of the United Manufacturing Hub, he created an integration platform that connects versatile assets to a single source of truth. That's a huge achievement. Hello, Jeremy. Thank you so much for meeting with me today. If you could briefly introduce yourself to the audience.
Yeah, so you already said, I'm Jeremy, co-founder and CTO of the United Manufacturing Hub. I'm responsible for everything with the community and also everything with product related. So I'm the head of product development here.
You realized the maturity of many manufacturing solutions and decided to create a product that enables professionals to digitize their shop floor. This is pretty huge task because manufacturing space is not an easy space if you want to transform and change how people operate, let alone to introduce open source technologies. So if you could give us a background of that crazy idea and how you started to get some traction.
So why do it at all? We originally started as a system integrator, and we were so frustrated with the status quo of the market. Like, we're a system integrator, and our task was, hey, let's go and just connect some machines. And all the tools out there, they cost like hundreds of thousands or even millions of euros. And we're working with a large management consultancy, and we're seeing how much money you can spend there without getting anything. And at one point it was like, come on guys, this cannot be it. And we decided to start with the Ming stack and then proceed from there on to build actually the UMH. And a lot of the issues, I mean, I could talk for hours, but this podcast is only an hour. So the typical issues that we've seen there are mostly because of the architecture behind it. There is the part where you have the automation pyramid, and I just released today in a blog article, Cloud Native Technologies on the Edge in Manufacturing, where I actually go into this much deeper.
You saw the obvious issue, as you just stated, with the manufacturing domain, and I absolutely agree with you. This is the same that I observe myself, but at the same time, I'm fully aware of the huge challenge of trying to change anything on the shop floor, because any hour that you disturb operations costs real money. So maybe you could give us that secret that you used to convince the shop floor managers to implement solution using open source technology instead of some huge brand, because as you said, the typical approach is that you purchase a software from a huge brand and you are covered, more or less, right? Then you just need to pay your bills and hope for the best. And this is totally opposite. You're saying that I will install open source technology on your hardware in the shop floor, essentially on the shop floor, right? And that open source technology is created by a number of freaks around the globe, but I promise it will be okay. So how have you convinced those people?
Okay. Yeah. So that is a very interesting question, and I think also the core of the conversation. So first, if you take a look at how modern software is developed, you cannot develop any modern software without using open source. This is not possible. If you take a closer look, for example, with the PLCs, you always get if you buy a PLC, you always get like a CD with actually what's on there are also all the open source projects and all the licenses that they've used. It is impossible nowadays to develop something without open source. The question here is not whether to use open source, but whether to use the free open source products. And the original pain is that these large vendors, in our opinion, they really messed up. So you can pay really a lot of money for these products, but actually what you get is really, really bad. And companies, they have been I mean, this doesn't change overnight. They have been, for the last 10 years, they have been trying there and giving them a chance again and again, buying a product there. But in the end, those large vendors, let's take a look at the historian market. It's a little bit crazy there because theoretically it's just storing some time series data. But companies pay, I don't know how many millions for licenses just to store a lot. Let's say, so what's considered a lot, like 30,000 data points. It's totally off the charts. Really, really, really bad. Like I would say at factor 10. This opens the opportunity for new stuff. As soon as you once work with modern IT, you know that 30,000 data points per second is really nothing. And then you realize, hey, wait, why do I pay here like a couple of millions per year for licenses? And there I get like almost for free. I get like most of the basic features. And then to get back to the original thing, so yes, we're using open source and we're also providing open source solution. But then what people actually use then, especially the larger enterprises, are actually like the paid versions for it. Because what they want to have is they don't want to rely on random guys on the internet. They want to rely on a company that does it. So this is also how we selected every open source component in our stack. It needs to have either very big community, so too big to fail, and or there needs to be companies behind it who can offer enterprise licenses, etc. behind it. So open source does not need to be like a random tool from some guy in Nebraska. It can also be something like HiveMQ has a community edition under open source license. A lot of MQT brokers are under open source licenses. It doesn't need to be something that you need to worry about.
So open source is only free when your time does not cost anything, essentially, right? Because in order to implement open source in a proper way, you need to have huge skill set, which is hard to get. And if you are operating a factory, this is not your core business, right? So probably hiring people just to handle that is not that good idea.
It depends. It depends on how you see also the future. I don't want to open too many things to talk about here, but also, do you see as this like a small part of the factory? Then no, it doesn't need to, and you would probably outsource everything. Do you see the digitalization and taking the information and doing something with it and using it to automate the process even further? Do you see that as a future, where in the future you have this vision of lights out factories? Then suddenly it doesn't become like this thing that you would outsource. And I think this is also, it's not now, but I think in the future we will head more towards this where all the producing companies, where there will be tech companies. And in order to do just that, they actually also need to start investing time and building their own solutions. So they need like the core competencies there. I know it's not, they don't have it right now, and it's not a thing that happens over the next five years, but over the next 10 to 20 years, it needs to change. You already see it. Some companies, the newer companies that you see like Tesla or Northvolt, they do build factories. They actually do it all in-house and build their own systems. And this is how they can achieve those great margins, because they can just implement all the fixes themselves.
This is a huge perspective change in the IIoT in general, that you own the whole vertical, right? And as you said, like they are building factories, they own every single asset on the factory, or at least every single crucial asset on the factory. And this is not only to cut costs, in my opinion, it is also to increase the agility, because once everything is virtual, to some extent, you can experiment, you can iterate very fast, and you can provide better quality outcomes to your customers, whether that are cars or whatever else. This is the same pattern. But let's go back to the design. If you could share crucial design decisions you took during the initial stages and how those decisions evolved over the years.
Yeah, so first, a little bit more on the architecture. So before we come to the design decisions, I think it's important to understand first the actual challenges that you have with the traditional OT automation pyramid. A lot of IT people forget it. That's you need the automation pyramid and you need all the technologies there because IT has not found a solution for it yet. So I talk about determinism, real time, etc., which is, to be honest, quite hard. And I don't think you'll find a cloud provider that provides anything that comes close to determinism. I think you worked at AWS, right? Or
Yeah. I used to be IoT consultant at AWS, and I used to work with huge manufacturers around the globe. That's why I'm so fascinating with your story, because I know the real issue there is, at the same time the huge lack of interest in changing the status quo in a way, because that's why whenever I see initiatives that put modern architecture within that old school legacy factory landscape, this is something that it brings hope essentially for me, right? That there is a way to transform those huge enterprises, and this is exactly what you're doing.
So I assume you know the automation pyramid. Like this is like how it's built up with multiple levels. Now, one of the challenges, especially if you just come from like a cloud perspective, is that how it works is every layer can just talk with the layer above it or under it, and it works very good because you have this system of control loops and you can have real time. It all works. But now if you come from the cloud and you try to access from above here, it will get quite difficult because first you have all the security stuff that's in there. So there's like this Purdue model where you have like the internet, the business network, you have all these firewalls, and then when you try to access the plant floor, I just saw it like I think 2 or 3 days ago. You have to go to log in via VPN, then go on the jump host just to connect another jump host just to control something on the plant floor. Totally crazy, which makes it kind of impossible practically to get access there. You also have the problem with aggregation because every time you go to the level above, there is always some kind of information lost. So there's, for example, if you take vibration data, here on the bottom level, it's sampled with a very high frequency, let's say 20 kilohertz, so 20,000 times per second. The PLC takes it, does a fast Fourier transformation, all this cool vibration analysis stuff. And then the SCADA system only gets like a vibration value or the average. And then the MES system only like vibration okay or not okay, and then when you try to access it from the cloud, it's almost impossible. You need to go through a lot of security steps, which basically impossible to get through that. And then also if you try to access the higher systems, you don't get like the raw data, which you might need for your application. So these are the challenges. And then how we've seen it usually implemented is, do you know the Namur architecture?
No.
What they said is basically, hey, they agree with all the challenges that I just said. Like they're just known from the IT perspective, like IT is not able to provide determinism and real time, but also from the OT perspective, all the challenges that you have, like you can't get data out of it properly, basically what I just said. And what they are proposing is actually like this dual approach. You have the automation pyramid. So if you take a look closely here, it's more like some kind of German thing, but basically what you see here is like the automation pyramid. And then they have like this, how they call it, monitoring M+O, where they extract data out of all of them, and then they build it up in a more highly reliable IT architecture. So it's not just us that's saying this stuff with the automation pyramid and the problems. These are companies like Bayer, BAF, etc. that all agree on these challenges.
This is actually a very interesting topic that you brought up. When you go up to the stack, you essentially lose amount of data, right? Because there are a number of reasons for that, and one of them is just from cost perspective. Because if you try to stream every single bit to the cloud, that would cost you a fortune, both for the API calls, network transfer, and probably your bandwidth between the factory and the cloud provider is not big enough to handle every single bit of data in the real time at least. And then we've got the approaches as you just showed, that we can send only aggregated data or maybe it's only essential data in the real time, and the rest we can store locally and possibly use like batch approach to feed that data back to the cloud, but not necessarily in the real time.
Yeah, that's also the second part. Good that you saw it. This approach here, where you have like this plan specific part, what you just said, and you have this cloud thing. So you leave everything like it is, and you have here where you have like also all the raw data, and then you might not send everything to like the central or the cloud. If you just go with just the cloud, it's really easy to get started, but then the cost will just explode ridiculously over time. Suddenly it becomes a business case thing because it will start to get really expensive, but it doesn't need to be. I know there's no like a side thing. We're all in for using the cloud, but sometimes you need to know what you should use through the services that they have, or where you should just simply use like a base EC2 instance. Or even for some use cases, we just made the experience. Do you know Hetzner?
No.
You can rent servers there, and they are like ridiculously cheap to rent. Of course, they don't have reliability, etc. They can fail. If they fail, it's fine. But they're like at 1/10 of the price of an EC2 instance. It is crazy. So we have currently like 20 virtual machines for internal testing running at the same cost of like 3 ones in AWS. This is also one thing. So if you're worried a little bit about cost of sending everything to the cloud, this is also something that you could take a look at.
This is something that is very important from the customer's perspective, because they don't necessarily need to be cloud aware, and for sure the cloud pricing is not an easy thing to figure out, at least till your first invoice, but then it's too late. So the thing what you just said is that you can advise the customers that there are a number of different options depending on the importance of the data, right? Because probably I don't want to make some cuts and save a few dollars, and then I will lose a critical alert and the whole thing will blow up, right? But this is not what you said. You said that it is perfectly fine to adjust your toolset to the value of data and the alerts and the reports that we are talking about. So if I lose a few bits of telemetry that is not critical, that's perfectly fine if I've got huge savings in exchange for that lack of 100% guarantee, for instance.
Mm-hmm. And I think what's important there is you don't need to do the decision right away. What's I think important is also coming back to a little bit to the topic, like one of the guiding principles of the UMH is to use open protocols. Let me explain later what this means. To use open protocols as at the core, so that you don't go directly all in on these services from the cloud with the biggest lock-in effect, but instead you rely on something. Let's just take MQTT. All the cloud providers all have at least one, if not even 3, MQTT as a service offerings there. So then in the future, if you rely on MQTT, you can decide in the future if you want to stay with the cloud vendor stuff, if you want to go maybe to something like HiveMQ cloud, whatever. If you want to self-host it, you leave all the options. And this is something that's really helpful from a strategic perspective, that you don't go at any point of time into, even when using the UMH, into some kind of too big of a vendor lock-in. There's always going to be one. But in case someone, cloud provider, starts rising the prices over the next 10 years, you can say no, or you can have a better negotiation strategy towards them, because they probably don't want to lose you as a customer by raising prices. You can just go there and say, hey, but then the alternative is I have a cheaper MQTT offering. You can't do that if you go like full closed source solutions there.
One thing that I always bring up if customer asks me about vendor locking, I say that vendor locking is always there. If you decide to use Python, you are vendor locked, essentially, because it is an option to rewrite all your application logic from Python to JavaScript or C# or whatever, but that is a cost and associated with it. And the same is true for cloud backends, for open source projects that you're using. You are kind of vendor lock yourselves, and there is always way to go out of that lock to some other option, but it will cost you money. So the approach that you proposed is very, very good, that try to use open standards and open protocols, because then at least you've got the option to switch parts of your solution without hopefully impacting the rest of your stack.
Exactly.
Let's continue with the actual open source projects that you're using under the hood to build the whole thing. Because it is very easy to claim that we've got distributed edge and cloud and open standards and whatnot, but very few people actually have done it right, and I believe that you're one of them. So if you could share the stack that you decided to use.
So we originally started with the Ming stack. So Mosquito, InfluxDB, Node-RED, Grafana. This is where we started with. And this was already like 10x better than a lot of the commercial solutions you find out there. Alone Grafana, the visualization tool, and you get it really for free. And for time series data, like it's really good. Over time, we did a lot of changes there. So we landed up with the current UMH architecture, and I can guide you a little bit through it. So first is we started by the Ming stack. We started by doing for simple Docker Compose. It's really easy to get started. But if you start to install it at a lot of clients and a lot of times, if you want to have how we saw it, like you want to have something on the edge and then something in the cloud, you are going to have a lot of edge installations. Docker Compose, you can do it, but it's not really possible to really fully configure it. You can spawn up the containers, but doing something like auto-generate a secret for InfluxDB and then put it into the Grafana data source. So as soon as you start up the whole thing, you have Grafana directly pre-configured. It will get difficult. You can maybe do it with being very hacky and doing some weird stuff, but it's like not really maintainable. And that was like one of the fundamental architectural decisions, why Kubernetes. We've taken again and again always a look at this, and we still think it's a right decision. First, we didn't go for Kubernetes because of Kubernetes, because you don't need the load balancing, to be honest. But what you need there is with Helm, you have an option to really configure a whole application consisting out of these multiple building blocks. So in Helm, you can easily do, let's auto-generate a secret, let's paste it into InfluxDB, let's then put it into Grafana, the data source, and you can do much more. And you can versionize the whole thing, which was really nice. And then additionally, one of the reasons for Kubernetes was it actually acts as kind of like a abstraction layer. Yeah, no, Kubernetes does not equal Kubernetes. There are a lot of differences. However, if you want to have the same stack and you want to pre-configure it, you can do it now in Helm, just a couple of configuration files, and the whole side, the whole thing of the application and the stack changes, because Kubernetes is kind of like the de facto operating system of the cloud. I don't know how you want to call it, but every large cloud vendor, everyone is using it in the background, and all of them have also like an offered managed service for it. So it is a good abstraction layer where you can say, okay, please give me Kubernetes, and then there's a high chance that you can just deploy the same stack on there as well. If you have a distributed setup with edge components, something on the factory level, and then something in the cloud, you can go for managed Kubernetes from the cloud.
There are actually two offerings. One is the Kubernetes, and the other thing is the Elastic Container Service, which is not full Kubernetes, if you will, but it allows you to manage containers. And just as a fun fact, you mentioned sharing the secrets between the applications on the containers in this case. That reminded me, a few years ago I had to do exactly that using Docker Compose, and I used the Docker volumes just to share files between various containers. It was hacking, as you said, like it is probably not something by the book, but it went well at the very end and worked. But I absolutely agree with you that, well, actually I've got mixed feelings regarding Kubernetes, to be honest, because I've seen so many really poor implementations by people using Kubernetes because everyone is using one. They expose themselves to huge security threat because it was not secured properly. They were not able to fully utilize the potential, and actually that went really bad for them in the long run. So I agree that the technology is for sure mature enough to be used, but it really raises the bar in terms of the skill set of IT stuff.
Yeah. So in our case, we have the expertise there, and what we do is also we don't use a full Kubernetes. We use actually like K3s, which is like a minimal version of it, which because you don't need. In the factory, you're never going to connect 100 servers in a cluster, whatever. You don't do it. The biggest thing you're going to do with 3 nodes or maybe 5 nodes for high availability. It's going to be it. But you can retrofit this high availability later on. So it's, I would say, still good foundation to build on. What we offer in our product is also the maintenance of Kubernetes. So it's an end-to-end solution. So we actually, I can come later to it. So the two things, would I recommend to manufacturing company to try to manage Kubernetes on their own? Probably not. They can probably spend their time on more valuable things. Can they use Kubernetes together with us commercially or as a community edition by using the UMH, where Kubernetes is pre-configured and pre-tested for certain operating systems, for certain versions that you have like ensure that it runs? I would say yes. So that's our take. If someone asks, hey, Kubernetes, but I fear Kubernetes, every time we release a new version, it goes through a whole testing pipeline. So we always ensure that everything that we have together with the operating system works in certain scenarios so that we can ensure the stability and find bugs before they happen in production.
I reviewed your portfolio, and one thing that caught my attention is the digital product shadow. If you could explain this concept, because it is very, very important and not always used as it should have been.
I did the original implementation. The idea is that because there are a lot of different names for digital product shadow, digital twin, in the end, you have a unique product which you can trace with the ID. And then every time in every step of the manufacturing process, you can put more information to that specific unique product. At least this is how it's modeled in the H. And this is like how it's treated. So, and this is also what we understand under digital product shadow, that you can then, at the later stage, type in the unique product ID, and then you can fetch all relevant information from when the time it was produced. From a database standpoint, it's not that difficult. The UI part is, I would say, is quite customized. So in general, what we do is we provide the infrastructure for it. We also will provide a dashboard on how you can interact with it. So everything to achieve customer success. But I wouldn't say like this is, if you compare 20 digital product shadow solutions, that UMH is the best of it if you just want to have digital product shadow. But where we are the best is ensuring that you don't have like another data silo, that you're using the same databases for all of your use cases.
I am a huge fan of the approach that you just described, and I agree with you that it is named differently, but the concept that you've got that bill of materials for product, and you can trace the quality of the final good all the way down to every single ingredient. I think this is huge, because for some companies, it is very important to improve the throughput of the production line, but the production line cannot work any faster. So one of the best ideas is to decrease the number of broken parts within the manufacturing process. If you can do that cross-check of the quality of the final good with all of those ingredients, and even, the aspects of how they were mounted on the good or whatever, right? Depending on the physical item, that allows you to find the crucial components, optimize them, and as a result, increase the throughput of the production line. That's why I think this is one of the very foundational services. Once you understand the potential, and then, of course, you need to put your domain knowledge, you need to leverage people working on the production line to actually analyze this data and provide hints for you. Because technology can do what you just described, gather data, use some analytics and present it in a nice way, but you need to have that domain knowledge in order to actually understand what you're looking at.
Yeah, And I would say a lot of OT vendors will say, yeah, all this data, this crazy amount of data. I wouldn't say that's the challenge. The challenge is actually giving it into a good user interface so that the operator, the one that has the process knowledge, can actually do something with the data. Because you need to have this trade-off between you want to do like a query because every product problem is a different one. So we can create a nice dashboard that will show you like general like quality defects and their reasons. But in order to solve a problem, you're going to need to deep dive into the data. And there you need to write queries. And now you need to give a process engineer the correct methodology so that they, in their language and their style, can deep dive into it. There are currently multiple approaches for that one. I think so far the Power BI or the BI tools approach works the best because it's not really suited for time series data, but a process engineer can work with it, or maybe just export it to Excel. They can somehow work with it. So this could be, I would say this is the most difficult part, like storing all the data. Okay, there's some data modeling involved. Again, it's not that much data. And if you come to bottlenecks, you can still optimize with a graph database.
Well, the data itself, you're right, but the true value is in the storing the context, not only the data, because the data without the metadata attached, it is just some noise essentially. So once you can store the raw data with the appropriate context and expose that data to the professional that is not necessarily IT professional, but they know their hardware, that really opens the potential. Let's go back to the open source, and one of the pushbacks when I speak with my customers, they ask what are the risks associated with using open source technology in their core components and the business processes. So from your perspective, how does it look?
Yeah. So there are, I would say, let's say two challenges. Like the first one is what is always thrown by some lawyers. The legal perspective is lagging behind the actual technological development. So it has been already for 10 or 15 years that you cannot develop a software without using open source. Like it is not possible. And so far, lawyers never really realized this. But as soon as they hear that someone wants to use open source, all of the alarm bells go off. Like, oh, crazy open source. No, we have to check all the licenses, and they go super crazy. Totally random, because you have to do exactly the same as you would do for any commercial product development. So you can split it up. The first part is where you buy from a commercial vendor. So as soon as you, for example, buy from UMH, there is a guarantee. In case there are any license issues, we as a company are responsible for it. And we have like our entire internal system to handle that. If you develop yourself, then it could be something, then you need to take a little bit closer look. So if you use those tools yourself so if you build your own stack, if you don't use UMH, if you build your own stack, you have to take a look at it. But it's just like a normal part of software development, and theoretically all the companies need to do it. So there are tools like, for example, Fossa, or there are other tools that automatically will check all the open source licenses used and will generate a report. I would say in normal, technical, mature companies, this is not a problem. There will be some weird dependencies there, but I've seen it myself. Most of them are like false alarms, or you can quickly, or the maintainer just forgot to add a license. We just had it like, I think a month ago, where there was a dependency flagged and was just a missing license. We just asked them and they put up the license online, and that's fine. But yeah, this licensing thing is it's just part of software development, and you have to take a look at. But if you just buy something, either from us or any other, if you buy from Grafana, you will always find these clauses included. So there's, also from a legal perspective, if you buy anything commercial, there's no need to worry. You're better prepared than if you were to take a closed source vendor, in my opinion. If you develop yourself, on top of it, it's a technical maturity of a development organization. As soon as you start building applications, you need to have some kind of internal process about it. But even there, it's not, even if a company would misuse a license, you always have to think also about the impacts of it. And the impacts, unfortunately for us as a as an open source company. The impact of misusing open source licenses are not that big internationally. There are also not many court rulings about it. So there have been cases where people or large companies have been misusing open source like really brutally, and they would have not paid. They didn't need to pay any cent of damages. Now going to the second part. So the first part was licensing of open source software, where you said, hey, it's no problem. The second one is also just if you develop yourself, not if you rely on any commercial vendor like either UMH or Grafana, or because there are both companies involved. It's if you use an open source tool where there is only like a one-man project or something like this behind. Because this is actually where you need to take a closer look. This is what we do. Every time we use an open source project, we look who's behind it. As soon as there is a company behind it that has commercial support, that depends on it, and that's a large company, let's say Confluent for Apache Kafka, there's a Red Panda's Kafka alternative, MQT, there's HiveMQ. You can be very sure that this product is quite good and that this will not appear overnight because some random dude got bored. But if you use single like project where there's no commercial entity behind, you do take a closer look. For example, Node-RED, there's also no commercial entity behind, which is kind of like, not so nice. But it is too big to fail. So there's so many people using it. There's such a big community with so many stars on GitHub that you can be ensured that this will not go away overnight. If Node-RED would stop to be developed, it would probably take 10 years or something. Same as with commercial vendors. But there are also like projects, especially for these connector libraries. There are a lot of libraries there which work, but it was basically just a single man project. And there, one has to be a little bit more skeptical about it if they really want to depend. So 2 big points: licensing, which is in reality not an issue at all. And then there's the second part, the choosing this. Is there support for it, either through a very large community or through a commercial vendor? And these are the only parts that you need to worry about.
I think those are great points. The checklist that you offered when someone wants to use open source project, what to look at? I believe this is great advice, that the commercial entity behind that or the established mature community, like for instance Linux kernel, right? This is like just
used to send satellites or the rovers, like how is it called? There's a rover somewhere on Mars flying around. We also using open source software, like it's so big.
Yeah, exactly. So it's mature enough to have at least a good chance of staying around for a number of years. What would you advise to a factory owner that just wants to start with the transformation? They've got some legacy systems, but they see the shortcomings of those systems, and they would like to experiment with a modern solution like the one that you provide. So what is the suggested roadmap, just to try to understand the potential value and gains from the factory owner perspective?
The first thing is this very big outlook into the future. So you shouldn't spend a lot of time doing like a big strategy, but to think about, okay, where do we want to evolve as a company in the next 20 years? So you have this outlook, and independent on what you decide, do you believe in this, that manufacturing companies will become tech companies or not? But it's a good guiding rail to help you with your decisions. So then you have like this long-term strategy. Then to get started, there are a lot of ways how you can do it. I can tell a little bit about them, and then their advantages and disadvantages. My preferred solution is, of course, get started with the UMH and the free community edition. There are multiple approaches there. One is to take like this silo approach, where you take end-to-end solutions, for example, like for maintenance. You go there, you implement them, and then they stay like this. And then you have a second or third solution, which is really nice to get started and to show the benefits of the digitalization. And you haven't done it, you should probably start with at least one, so that everyone's, also the older generations in your company, get used to, digitalization, it makes sense. But then, in my opinion, you should not go any further, because this is usually not scalable. Because if you have one solution which works great for maintenance, and then you have one for OEE, they all need to share the data. They all need to use the same data. So you need to have like a common data infrastructure. The more solutions you add, the more complexity you have and the more costs you have in implementing a new one. So start with one, show the example there, how it's working. If you are a more younger company, then you can just switch directly to like a first draft of your infrastructure. You could use something like the Ming stack, maybe good for prototyping. I would say, but I cannot be neutral on this, to say, okay, use the open source version of the UMH or the community edition because it is free as well. You get a much better improved Ming stack. You can potentially get commercial support for it, but you can get started with your data infrastructure and to show there the proof of value. So also to see, hey, let's build one use case on top of it. Yes, okay, that was maybe took more time, but now I'm adding more use cases and it suddenly goes very quick. That's because this is the advantage of a shared data infrastructure.
Starting with one very clearly defined goal and using the proof of value approach, this is what I suggest typically, because only then you can actually measure if the whole initiative provided the gains you want or not, right? And I absolutely agree with your approach that try not to go too far into the future where you do the analysis, because then it is basically not possible to predict all of those variables. And when you are just starting with IoT solutions, then you probably don't even have a clue about the potential of how your company can leverage all of those capabilities. So trying to predict a few steps ahead without knowing the tool set that is available for you, that is just a waste of time. Start with something small. Do not be discouraged by the time for the initial implementation. As you said, the first deployment is always the hardest. You might even fail a number of times, but once you build the foundation, the framework, both in terms of the IT and your internal operations, then adding additional business use cases on top of that framework actually pays the benefits. So this is what I would suggest as well.
There's one addition. If you have this base data infrastructure, but you didn't use open standards, etc., then you will also get in a very bad state. I've seen it with companies, now my favorite topic, OPC that went with OPC as a middle ground for everything. Believe me, there are a lot of architectures that you can do by just drawing OPC in the middle. Those companies are now really, really struggling because they did not have like some kind of openness or different protocols that are possible in there. It might happen that you build up on an infrastructure that will just result in a dead end, which is dangerous. But there you can just, this is my tip for this, take a look at how other companies are doing it. And don't only look at manufacturing companies, because for a lot of manufacturing companies it's all new. You can take a look at companies like Tesla or Northvolt. They're using modern IT tools and best practices to do just that. You can take a look at there, or you can also look at traditional IT solutions, how they manage the data. And yeah, there are also other approaches to what we use as UMH that could also be perfectly fine, but there are also a lot of approaches that will kind of like end in a dead end. I don't know, like if you start sending all the data to a database, for example, that's going to be a dead end for all the real-time use cases. If you use OPC UA for everything, that's also going to be dead end. If you just send everything into the cloud, that will also be likely dead end. So there are a couple of dangers where I think we've written really a lot of blog posts about. So, and if you can try to avoid those big pitfalls, I think it's fine to just go experiment around, even though I would say, of course, the UMH is the best way to get started.
Speaking about UMH, what is the next big thing on your development roadmap? Are you willing to share that secret?
So the next thing are actually data contracts. We've been also sharing it in our Discord channel, and we've been using them for ages now, but we were never really able to pinpoint them. And with data contracts, what you can do is you can start formalize the interactions what you have in a unified namespace. If you build like your unified namespace architecture with like message broker in the middle, it can get quite messy fast, and it's hard to model things around it. You then can use modeling tools, but it can still get chaotic. And with data contracts, there's like a IT best practice approach that you can leverage to structure and model your unified namespace. There will be in the next couple of recent blog article with like a sample implementation on how you can do it with the UMH management console, how you can get started with it, how you can do your own data contracts, how you can do things like, I have now a payload going around and I now want to store it in a database table, how you can do it while still having the organizational maintainability that you can work with multiple people on it and it doesn't get lost in the organization. This is the next big thing that we're working on without going too much into the details.
Yeah. So it sounds exciting. So I will be taking a look at your blog posts and following that development. Last question. What is the best way for manufacturers to reach out to you to learn more about the modern industrial Internet of Things capabilities and hopefully to start the cooperation?
Yep, so the best way to get started is to visit our website. And there you can take a little bit more about the explanations, but also you're going to be presented with two choices. One is to go try it all on your own. There's a free community edition. Go there, enjoy. But there's also the second way where because it can be difficult to get started in enterprise environments. There is also the second option where you can contact us and we help you in getting started with everything. And then you can, again, play around with your own. It's just that we help on the initial installation step. And with this, you should have enough to visualize unified namespace, to show it, to work with it. In a couple of weeks, also work with data contracts. You're going to have like a simple visualization tool where you can visualize time series data and relational data. So there's a lot of it in there, which should definitely be enough to get started.
Perfect. Jeremy, thank you so much for joining us today, for sharing the best practices of how to use open source in the industrial Internet of Things deployments. I think this is very, very important, and providing that knowledge and hands-on experience is extremely valuable for the whole community.
Yeah, thank you for inviting me.
Thank you for listening. Go to the thingrex.com to find more materials about the Internet of Things domain. I'm your host, Łukasz Malinowski, the Internet of Things advisor and trainer.